Okay, in this video we're going to look at a word problem involving calculations from a normal distribution. So first off, let's talk about a normal distribution. So when you have a normal distribution, if you were to take all of your data and plot it along an axis where we look at the mean, right, the average. So the curve that would be generated would look like this. This is called a normal curve. So the normal, this is a normal curve. And so what that is showing us is that most of the data starts to accumulate around the mean and then tapers off on either side. So the further away from the mean you go, there's less data. So most of the data is around the mean. Now, if you remember, there was something called a standard deviation that measured how far spread the data was. And so if you were to calculate the standard deviation and add one standard deviation to the mean. So if I have this marker here, which would be the mean plus one standard deviation, and if I subtract the standard deviation from the mean, and I have the mean minus a standard deviation, there would be, just in this area from here to here, would be 68% of all of the data in the curve. So just this kind of area is 68% of all the data. Now, if you go further than one standard deviation, let's say you go another standard deviation out here, so now we're looking at the mean plus two standard deviations, and if you go back another standard deviation to the left and do the mean minus two standard deviations, now we're looking at, if we went all the way from here to here, we have even more than 68% of the data. Actually, 95% of all the data is between two standard deviations from the mean. And we're going to go even one more step. Let's say we go 3 standard deviations from the mean. So we go out here, so we do the average plus 3 standard deviations, and back here we'll do the average minus 3 standard deviations. Now if we went so far as to go from there all the way 3 standard deviations, I probably should have wrote this, that would be 99.7% of all of your data. So nearly all of your data has to be between 3 standard deviations plus or minus from the mean. So this is going to be the picture that generates everything that we do in these problems. So it's going to be important to keep that in mind. So what's nice is they give us everything we need. So the batteries from a certain manufacturer have a mean lifetime of 820. So right now, I know that my mean is 820. I don't even have to calculate it. And they give me on a silver platter the standard deviation of 90. So I know my standard deviation sigma is 90 hours. Assuming that the lifetimes are normally distributed, complete the following statement. So we know it's a normal distribution. We have to kind of fill in the box here. Approximately blank of the batteries have lifetimes between 730 and 910, and approximately 95 of the batteries will have lifetimes between blank and blank. Both questions are going to be answered by simply drawing the bell-shaped curve, or the normal curve. That's kind of not a good one. It shouldn't have that. It should be like that. Now, right smack dab in the middle is our mean, which is 820. Now remember, from the mean, we're going to go add a standard deviation to the right and add another and add another. So the standard deviation is 90. So if I add 90 to 820, that would put us at 910. That's one standard deviation away. If I add another 90 to that, that would put us at 1,000. And if I add another 90 to that, that would put us at 1,090. That would be 3 standard deviations. So here's 1 standard deviation, 2 standard deviations, and 3. Then I have to subtract 90 from that to take me 1 standard deviation to the left. That would be 730. That's one standard deviation. If I go another 90 less than that, that'd be 640. If I go one standard deviation less from that and subtract another 90, that'd be what, 550. So let's see if we can answer the question. How much of the batteries are going to have a lifetime between 730 and 910? Well, look at 730 and 910. Man, they picked perfectly, and they will. The first standard deviation numbers, which if you remember was 68%, right? Between here and here is 68%. So I would say that's going to be 68%, Alex. Okay, now approximately 95% of the batteries will have lifetimes between what and what? Well, you got to remember 95% was 2 standard deviations. So two standard deviations in this problem would be 640 to 1,000. Right? That's 2 standard deviations. So I'd go 640 to 1,000 hours, and we'd have it. I hope this helps. Thanks for watching.